data. He should be able to handle that kind of mentality, that kind of functionality. So we'll be talking about that, Gaurav, in a little bit, like uh, in a minute. So let's just revise what we have, like what kind of knowledge we have. It's a layer one device. So you connect your end host, and host are the device for whom you are building the network, your computer, my computer, servers. For example, I'm building a network. So what is happening whenever any device connected in that network that is having hub, if like for example PCA is sending a data to PCB, guys, according to this requirement, what can you assume? Is it a broadcast message? Is it a multicast message, or is it a unicast message? The requirement is what? When PCA wants to send data to whom? To PCB. Tell me, is it, what does it represent? Is it a unicast message? Is it a multicast message? Would it be a multicast message, or
Unicast.
PCA should do broadcasting? Tell me. Unicast, because PCA wants to send data to a single destination. So PCA will have that particular data, and he'll need to add additional information, such as the most important information, source IP address. He'll add his own IP address. He'll also need to add to whom he want to send that data. Destination IP address should be also available above that data. Additional header at layer 3, you know that. And at layer 2, what is the most important thing? Source MAC address, and yes guys, destination MAC address too. And I hope, and there are multiple more important additional information that are required, but right now I'm just using the most important. These should be there, 100%. These should be there. Done. So after you have having this kind of information, so the destination IP will be of PCB, and the destination MAC address will be of PCB. So PCA is confirmed that I want to send a unicast message. So he'll be sending out the data from the physical layer. He'll compute the data from layer 7 to layer 1, and from layer 1 he'll send out the data on the medium, on the whatever the medium is, whether it is wireless, whether it is wired, and what kind of cable you are using, fiber cable or like copper cable, according to that. So basically we are transmitting our signal. When these signal are received from one of the port, for example, when one of the port of hub receives the signal, he is a dumb device. He do not learn anything. He do not see, he do not check anything above the data. He do one thing, he just know one thing. Whenever he receives the data from any of its port, he needs to do what? He'll always do broadcasting. He'll always do broadcasting automatically. PCA wants to send a unicast message, but the functionality of hub to receive data and transmit it to the appropriate destination, the functionality was he will be broadcasting from all the port that are currently used. For example, it's a six port hub, but currently we are using 3 port. So from all the port that are used, it broadcasts the same message. Always, guys. Right now, PCA is sending, so he'll also do the same thing. If PCB also wants to send data to someone else, whenever a port receives data of the hub, it will just broadcast the data from other port. And why? Because there was something, there was a logical concept behind that. In yesterday's session, we talked about 2 things, and these are very important things, guys. You should be clear of what is a broadcast domain. A domain where basically an area where the broadcast message can be received by every device. I'll be telling you what is broadcast domain. And another thing, collision domain, a domain where collisions can happen. What is collision? Your data are colliding with each other, and if collisions are there in your network, that is bad, because your data is getting corrupted. Okay. So that is one thing. Like if this is one scenario. Okay, and another scenario, I'll like if in the same network PCA wants to send a broadcast message. Now the second requirement is PCA want to send a broadcast message. So what he'll be doing, PCA will be having that data that he want to broadcast. He'll be adding his own IP address, PCA IP address of its own. The destination IP address now will be not a unicast, will be a broadcast IP address. It will be what? It will be what? It will be a broadcast IP address. And I hope you remember what is the broadcast IP address in our network. The last IP address in our range that is provided by the network provider or network admin, the last IP of the network is used to do broadcast within that network. So you'll be adding that IP over here. Done. And the source MAC address will be, who is sending? PCA is sending. And guys, if I want to do broadcast, now I'll be not having the destination MAC address of any single entity. Just like you are having a broadcast IP address, guys, you are also having a broadcast MAC address. You are also having a broadcast MAC address. So that is universal. Your broadcast MAC address is universal for everyone. For me, for my network, for your network, for everyone. What is broadcast MAC address? Yes, guys. Anyone have doubt? Okay. So if I want to tell you what is broadcast MAC address, guys, see, basically MAC addresses. If I tell you about MAC address, let's learn a little bit about MAC address, guys. As you know, IP address. If I ask you about IP address, IP address comes in which version? These come in two version: IP version 4 and IP version 6. You are well aware of IP version 4. We'll cover IP version 6 later on, but not right now. So you know a lot of IP address. How does a computer understand IP in binary format? How does we understand in decimal format? We have 4 octet. That is good, guys. MAC addresses are provided by your manufacturer, the manufacturer of your NIC card. Okay, and your MAC address contain 12 character. How many character you will see in your MAC address? 12 characters, for example. And these characters that you will see in your MAC address are in which format? These are in hexadecimal format. In which format do we represent MAC address that human can understand? In hexadecimal format. uh, let me ask TJ, are you there?
Yes, I'm here.
Sir, do you know how many characters are there in hexadecimal? How many possible values are there in hexadecimal? Start
Uh,
0, 1.
I know it's
You don't know?
16.
Yes. Let's see. 0, 0, 1, 2, 3, 4, 5, 6, 7,
8,
8,
9,
9. And
A,
after,
A, B,
A,
in
C,
B,
decimal
C,
we
D,
have it.
F.
Yes. After 9 we also we have A, B, C, D, and E, and F. So these are the possibilities of character that we can have in hexadecimal format. So your MAC address will be represented in hexadecimal format. And how many characters do we require? 12 characters. So let me find out my MAC address. How do you find a MAC address on your computer? Simply go CMD and type ipconfig/all. Guys, this is the command to find your IP and lot of other information related to your network. If I press enter, you will see a lot of information. Just for right now, just search for, like, I am connected to Wi-Fi. Right now, my laptop is having NIC card for wireless connectivity and also for wired connectivity. It has both capability. So that's why you can see wireless LAN adapter, wireless NIC card, and this is Ethernet NIC adapter. This is for Bluetooth. You can see with the name. This is VM. This is VM. This is VM. Yes, this one is my NIC card for Ethernet port. So you can see the physical address right now. The physical address is your MAC address, and this is my computer's Ethernet MAC address. A029192899973. And if you count, how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 characters are used to represent your MAC address. So let me just go and write it over here. I'm just dividing the screen in two parts. So for example, I'll write my MAC address. Okay, A0-29-19-2A 99-73. In your IP address you separate this character by dot, but in MAC address we separate this value by hyphen or dot also. So see, basically you can also see your MAC address represent in this format, and the same MAC address that you are seeing on my screen also be represent in this format also. See, A029.192A.9973. Both are valid format to represent your MAC. So do not get confused if sometimes you see your MAC address represent in this format or in this format. Both are representing the same thing. Is it clear? And you can see these value are only in between these characters. That is good. So every computer will be having a unique MAC address. No computer in the world are having duplicate MAC address. If it happens, it's a flop. Okay. So it's compulsory that every device in the world should have a unique MAC address. Done. So guys, there's one more thing. Uh, in your MAC address, basically, guys, in your MAC address, you can find two things. By just looking at your MAC address, the manufacturer are adding some information that that you must be aware of, guys. The first six character, are your
Manufacturer.
yeah, are provided by your manufacturer, OEM. Okay, are these are provided to your, for example, I'm buying a NIC card of Cisco, for example. So Cisco is having a fixed first six character value that will be used in every MAC address, same value. But the last six characters are like totally independent. These characters should be unique. When we combine both of them, it make unique. So like in world, there is only not Cisco over there. There are multiple more vendors that are making this kind of hardware like NIC cards and other thing. All the vendors will be having a OEM part in your MAC address. So by just looking at the MAC address, what we can find, like from which manufacturer does the MAC address was provided for, and what is the part that manufacturer is using that will be unique within that in his like system. So the first six character, by looking at the first six character, you can find from which manufacturer the MAC address was made from. Okay, so like see if I go on MAC address lookup, there's a website called MAC address lookup. So basically, this part is all the main name is known as OUI, Organization Unique Identifier. What is the full form of OUI? Organization Unique Identifier. Basically, every manufacturer will be having its own OUI. So see, let's go and copy my MAC address. It's a complete MAC address. Okay, copy it. And if I go over here and search it, so basically I'm writing the whole, but just if I just write the first part and if I do a searching, see here, let it search. It is registered and the vendor. So see, this manufacturer is who is the manufacturer of my NIC card? Dell. So this is how you are able every okay. So by just whatever NIC card Dell is producing, he's adding the OUI value in the first. That will be common for all the NIC cards, but the rest six characters are unique within it. And guys, if you think like do we have infinite? So basically, what companies are doing? Companies have multiple OUI purchased. Like Cisco have multiple OU. Cisco definitely have multiple OUI value. Okay, otherwise these will also get empty. Done. So by just looking at the MAC address is very important. Now you know a little bit more thing about MAC address. Done. So this is the MAC address of my computer. But guys, see here, as I told you, there is a broadcast MAC address also, guys, and that broadcast MAC address is universal. That is 12 time F. That is 12 time F. F F F F F F F F F F F. Or you can represent the same MAC address in this format also, FF hyphen FF hyphen, both are valid. So if any device want to do broadcast, so he'll be adding what? He'll be adding the broadcast IP at a destination, and he'll be adding the broadcast MAC address. That is what is the broadcast MAC address that you can see in your screen. And if someone want to send unicast, so definitely they will need to have the destination MAC address. Then, so see, so in the second scenario, like we were discussing about hub. Okay, so even if in the first scenario PCA wants to do a unicast message, my hub was also doing broadcast. And if PCA wants to do a broadcast, now PCA wants to do a broadcast still. So he'll be adding these information, and these information, like let me draw the network over here so that. So if PCA, PCB, PCC, so if PCA wants to do a broadcast, he'll be adding these information and will be sending this data to the network with the whatever medium you are connected to. When hub receives the data, he is not checking anything. He's receiving some signals and he is doing what? He is broadcasting it out from all the other devices. So this is good for this scenario, but this is bad for when PCA wants to do multicast or unicast. In that scenario also, he's sending the data to all the other device in your network. And why? Because in logic, in what is the functionality? There's two main thing: broadcast domain and collision domain. So all the ports, remember this thing, all the ports of hub, how many broadcast domain are there? All the ports of hub belongs to a single broadcast domain. Is it clear? Just like so, see here, guys. Now I hope you have Cisco Packet Tracer installed in your laptop. If you do not have that installed, please ask me. I'll share. You need to go on Cisco's website and download this Cisco Packet Tracer for your laptop. Whether you have MacBook, whether you have Windows, for all the versions of all the operating system, we are having Cisco Packet Tracer available. But download it from Cisco's Net Academy. Okay, that website that is official. Okay, done. So see here, let's build a network just by hub. I know it's crazy, we don't use hub these days, but still, let's see what is happening over here. Let's build PM networking network. So we have, like, so see here, you need to go on compute PCA, then you need to, because we in a network we have multiple. So what you can see, I need to go and select on PCs. Where you will find PCs in your Cisco Packet Tracer, you have multiple things. See here, we have networking device, we have end devices, you have components of your computer, you have this electrical board signal where you can see my cursor is moving. This is for your cable part and multiple more. Right now we are not exploring Cisco Packet Tracer, we are learning network. We'll also explore Cisco Packet Tracer because this is the best software to learn networking. Free, easy to use, and not too complicated. So see, I'll go to the end device. As soon as I click end device, there are multiple more options available over here. But for me, if I click end host, and you will see like PCs, laptops, servers, Meraki server, network controllers, cyber observer, lot of things, voice over devices, printer also, guys. So we'll build a network. So see, if you want to select a single device multiple times, so what do? A shortcut is there. Instead of selecting it again and then going pasting it on your on your screen, then going again, what we can do is just before selecting the device, press Control button and then select the device. After when you do that, then for a longer period of time, the device is selected. Okay. So we have multiple devices. For example, 6 plus 6, we have 7 devices. We have, okay. So these people are sitting on a different room. These people are sitting on a different room, and let's suppose, so right now let's suppose to build a network I'm using hub. So right now I have n devices over there. Okay, now I need a networking device that will help to build a network. So for first device, that was hub. So I'll go for the first option, networking device. Then you can see routers, you can see switches, you can see hub also. So I'll select hub right now and select the first device, that is PT hub. So let's suppose I'll in my network I have two hub. So see, if you want to select a device from multiple times, just before selecting it, press Control button and then select it. Okay. Now after doing that, you need to provide connectivity. So what we'll do, we need to add cables to connect your devices. Okay. So right now we'll go to the lightning bolt option, and because we are not aware of cables, according to me, I haven't delivered you concept about cables right now. For right now, you will select the first part, that is automatic. The first option you will are having here is it's automatic. I'm pressing the control button and then selecting it. So for that, because I need cables for a longer period of time, I'll click over the hub, and one end of my cable will be inserted to the hub and another end on the PC. Same I'll do with the other thing, other devices. Let's suppose these three are connecting to this hub, these four are connecting to this hub. But what I'm building my single network. Done. And you need to provide connectivity between your hub also, because network is what connecting devices so that these can share data. Network is just like a road. If you don't have a path, you can't send data. So right now, hub were also built to use a single local area network. And inside your local area network, what kind of addressing do you use, guys? If you are using IP version 4, you are having two IP address, private and public. So you will be using private IP. So guys, I am choosing, because I am the network engineer, the network ID I am choosing, selecting is, let's suppose, 172.16.0.0/24. The network ID I'm choosing is 172.16.0.0/24. Let's suppose I do not have that much of requirement. So with /24, we'll be having a network that will be having 256 IP in total. So right now, according to my lab, it will fulfill. So I'll assign IP address according to this. So guys, can I know the range? If you're having a network ID of this 172.16.0.0/24, can I get the complete range? What is the broadcast IP address of this network ID? If network ID is this, what is the broadcast IP address?
172
One
dot 16.0.255.
0 dot
255.
255. Nice. Now you are also able to identify what are happening. Okay. Then soon you know the complete range. So from which IP we can start assigning 172.16.0.1 till 172.16.0.2. Okay. Or not 254. Okay, the last valid host. So now you know the range. So network engineer needs to go to every device, have to have the access. I'll double click on the device. I'll go and click the desktop option over here, and this is within your packet tracer because this is network simulation. So, you will want to do the same thing. You need to have access of a computer. You should be able to know what is the method to assign IP address on that computer. You are well aware of that, but you're learning according to the packet tracer. You'll go and find the desktop option and select IP address. Right now, we are not using DHCP automatic option. We are manually providing IP address that is static. So for right now, we are only building a single network. So hence I told you need only two things. One is what is the unique IP address within this network 172.0.1 that I'll assign, and the subnet mask will be not you will not the subnet mask will be not according to the classical. We are using classless. So the prefix value we were given that was 255.255.255.0/24. That's all. You do not need default gateway. You do not need DNS server. According to the top lab we have just built. Done. I'll copy it and I close. So we can close it. I'll go to every device, guys. Give me 1 minute. Just see me assigning IP address to each device. 172.0.2, 255.255.255.0, and close it, guys. Dot 3. Yes, if you have doubt, you can ask. Meanwhile, I'm typing. Zero dot 67 255.255.255.0. Okay, that's all for right now. Now we have just built the network, and after building network we need to check whether you have provided connectivity, proper connectivity, and you have provided the appropriate IP address to these devices. So according to the scenario, according to the lab you're having, now you have built a single network. You have 7 devices within this network, and now these 7 devices can communicate to each other within this network. So let's try to check whether we are connected and whether these devices can send data or not. So the first command that you will use in your network, that is ping. Guys, ping is a command. It's a command, and very important command to check network connectivity. Ping command, okay, used to check connectivity, and between whom? Between source and the destination to whom the user want to send data. So ping is just used. Sometime what happen? I'm not able to send data to the destination. So what I'll do? I'll use this ping command, and I'll try to check whether we are connected in the network, whether we'll be able to send data or not. If ping is successful, that means we have path and we can share data. But there is some issue with the service on that we are using to send data. Okay, so how so after you type ping command, and after this you type the destination IP to whom you wanna check connectivity. So right now, as I told you, so what we'll do, we are on PSE1. We'll go over here. We'll go the desktop option, and we'll select command prompt. This is basically same like your command prompt that you're having on your Windows computer, maybe your MacBook. In MacBook, it is known as terminal. In Windows, it is known as command prompt. So we have ping command over here, and we can ping that we need to have the destination IP address to check. Okay. So if ping is successful, that means we are able to send data and receive data from the destination also. So right now, see, I try to ping something, but this IP does not exist within my network. So that's why I'm not getting any reply. I'm not getting any reply from the destination. So ping will do what? See here. So let's try checking connectivity. I'll go to PC1, and if your screen is also like, if the characters are very small, what you can do, just go to the option field, you go to the preference option, and you will see font option over here, and this in within your CLI, just increase the font size. Let's make it 13. Apply it, close it, again open it, and check your command prompt. You will see a little bit of the font size will increase. Okay, so I'm on PC1. I'll try to ping PC2, and PC2 IP is 172.16.0.2. Guys, see, now I'm sending data from PCA and to whom? To 172.16.0.2. Guys, is the destination IP belonging to a different network or same network? If the destination IP belongs to the same
Same.
network, so the hub, or in nowadays switch, will be with the help of only these devices, you'll be able to send data. We do not need any router. See here, I try to do ping, and I'm getting a reply from whom? I'm getting a reply from 172.16.0.2. It's a the data, the ping command is using a random data to check connectivity, sending a random data to the destination, and the destination needs to reply for that particular request. So within ping, two things are happening. When you send a ping, guys, when you send a ping, your computer generates a message that is within ping, and that is basically a request message. This request is that if the destination is there and if the destination receives the data, he needs to give a reply of that particular request. So if the path is there and data goes to the destination for whom that ping was generated, the destination needs to reply, give the reply back for the ping. And if we are getting the reply from the destination right now, that means there is connectivity. We can send data to destination, and destination can also send data to us. That means two-way connectivity is there. We are not only sending data to destination, but destination can also send data back to me. That is hence proof. Okay, let's try to ping other device. Ping 172.16. So see here, ping 172.
मैंने एक बार भेजा था, कोई किसी ने हार्ड का कर पाया था.
Guys, your voice, guys, please mute
Sorry,
your.
sorry,
No
sorry.
issue, no issue. Done. So guys, let's go back to the lab, and we are over here, PC1. So I'm pinging PC3. Let's ping. I'm getting a reply back from it. That's good. That's good. And see, if I try to ping the last device that is having IP 0.7, so let's see, because the destination IP is within my same network, and you have built the network, you have multiple hubs, and also the path between them. These devices can send data and receive data with the help of network. So with the help of commands, we are able to check whether the network that we have built is properly working or not. But in Packet Tracer, you can also visualize it. How? Go to the command prompt of your device, and before sending the data, you have two options over here: real time and simulation. So this is in real time, you won't see any packet flowing in your lab, but as soon as you select simulation, so in simulation, right now you're not seeing any packet. But see here, I selected simulation. I go back to my command prompt for PC1. I'll type the same command. Let's try ping 172.16.0.7 again. So as soon as I press enter, now you will see step by step of flowing of data. See, a data is generated by PCA. As soon as you click ping, as soon as you like do something, a request message is generated, and a request message within of ping. Now that message will be that it's like see on the right side of your like on your screen, you are seeing this. So the first message is of ICMP. We'll talk what is ICMP. Double click on it, Guys, you won't be seeing data, but you will be able to see additional information that was added by this computer. Can you see? At layer 3, he has added who is sending the source IP addresses of whom 172.16.0.1. Okay, and the destination IP is 172.16.0.7. After just learning about the destination IP, PCA knows that destination is within my network, so that is good. And so at the layer 2, what we are adding, who is sending the source MAC address. This is the first MAC address of PCA, and to whom we are sending, to PC7, that whose MAC address is this. I'll confirm the MAC address also. So you need to have those information. After you have those information from your physical layer, the data is sent out. Okay, now what is happening? Your one of the port of hub receives that data. Guys, this is it unicast or is it broadcast message? It's a unicast message. PC wants to do unicast, but the functionality of hub you are aware of. As soon as hub receives the data from any of its port, because all the ports of hub belongs to a same broadcast domain, belongs to the same member. So if any of the port receives a broadcast message, if any of the port receives a broadcast message, it will be delivered to all of the, from the to all the other port, because all the other ports are also belonging to the same broadcast domain from the port where it was receiving the data, because all the ports are belonging to the same a single broadcast domain. So see here, my hub is not delivering data to not only sending data from this particular part, it's delivering to all the other devices. See here, these PC, because in network those PCs are very closer to the source, will receive data very soon, but those PC, those devices which are away from the source will, as you know, because network is also a partner, it will take time to deliver data to those people. So now see, so the same message is delivered to the hub 2 also. It was broadcasted. So now so now hub receives a data, because it's a dumb device, it's a layer 1 device, it does not read any information above the data. It simply do what, whenever I receive data from my port, I need to do broadcast from all the other ports. See, so he'll also do what, broadcasting. So all the other device will drop, because when they receive the data, they are checking from the layer 2, layer 3, and confirming whether the data is for them or not. If data is not for them, they'll drop. But if the data will be received by the destination that was meant for whom the data was meant for. So as you can see, it was meant for PC7. So PC7 accepted, he's not dropping. He receives a ping request, and he knows that if I'm receiving a ping request, I need to give reply back to the sender. So now see, now PCC generate a ping reply. Now what? Now see, the same message was delivered by PC1, but now see, this message, the message that I have highlighted, this message was generated by PCC. So now when PCC generate a new message, he'll let me make it backside. So when PCC receives a message, he'll do what? He'll add, when he's replying back to the source, he'll add his own source IP. Destination IP will be of whom? Of PC1. Source MAC address will be of him, and the destination MAC address will be of PC1, because he's giving a reply back. It's a new message. So when he's sending the new message, replying, it will go back to my hub. Hub receives a message that was meant for unicast, that was meant to be unicast, but the functioning of hub was, whenever he receives data from any of its port, it's to broadcasting. And that's how, see, the destination was successfully, it received the first reply. Now the first reply was there, but in your background, when I saw without when I like, show you the same representation without simulation, you saw 4 reply. So yes, 4 requests were made and 4 reply were all there. So there was no packet loss. You sent 4 ping message, you got a reply for all of them, and no packet was lost. So that means network is working fine. You can send data and receive data from any other application. Network is not the problem now. Network is there and you can send data. Done. And the second thing guys, let me go back to the notes. You need to be aware of collision domain. And what is if I ask you about collision domain of hub, all the ports of hub belongs to a single collision domain. Guys, this was the problem. There were multiple different port, but in logical they have a single path to send and receive it in a logical way. Okay, so what is happening when at the same time two devices try to send data? Collision will happen. What will happen? collision will happen, guys. So see here, to represent you collision, let me do one thing.
Uh, hello,
Let me show you collisions. So just
hello.
yes, sir. Just switch back to your real time. Yes, now you can ask, sir.
No, no, open the like simulation part. Like there is a showing out layer and in layer. What is that?
Okay, okay. Outlayer. Outlayer is when you're sending the data, and in layer is when you're receiving the data.
Okay,
That is the that is right now. I have just removed it. I have selected real time, so it is not there. I'll when I'll show you another thing. I'll. But is it confirmed? Out in is when you're receiving, and out is when you're sending data from that port.
okay, okay.
So guys, see here. Just see the above topology. Okay. So we have three. We have the network over here. So what we'll do? I'll select. Uh, Let me show you. We are able to communicate within this network. So do not choose terminal, choose command prompt. Remember that terminal is for something else. Okay, ping 172.16.0.3. This is one, this is two, and this is three. I'm sending a ping message from two to three. Okay, this is right now only one person is using network. No one else is sending. Okay, because this is made by us. And let me show you connectivity from this device also. Let me ping 172.16.0.2. We are able to send and receive a reply back. So see, let me before doing it now, no one is sending data at this time. No one. So let's do one thing. Just go select our simulation mode and go back to PC. This I'll try ping 172. So I'm sending data to a device. Right now, this data is not delivered in the network. It's held in within my computer because we are using simulation. Now let's go back to PC3, and let him also ping to someone, to the same person. So you can see now two persons are there and they want to send data at the same time. That is the common need in network in 2025. We can send data at the same time. Okay. So right now in this scenario, person want to send data at the same time, and if they do that, what will happen in your network? Collision will happen. You can see this symbol. This is symbolizing the collision were there, and all the device will receive a collision collided data. See here, and this collided data is not of any use for any one of it. You can see the special symbol of getting, this is showing collision. So in hub, when multiple devices were sending data at the same time, collisions were happening because yes, there were multiple port, but in logical in logical concept, they have all the port belong to a single collision domain. A collision domain is a domain. It's an area where collision can happen. It's a path. You can think like that. That was the main problem. So in yesterday's session, I told you they use a method called CSMA/CD. This particular technique was used in the network we are having hub to avoid collisions. But still using this concept, collision were not totally removed. There were still collisions. So they have their methodology that I have discussed you to yesterday. But the special part, but the more thing about like if I ask you, there were one more problem that all the ports of your hub, guys, where is the, remember one thing, all the ports of your hub works in which duplex mode? Works in half duplex. And this was also the issue. The ports that are having, they can send data at a single time. They cannot send and receive data at the same time. So hub do not have any special memory, that is that you are aware of. So we'll talk about switch and also see how switch work. So switches are modern devices. These are the upgraded version of hub. So to represent a switch, you have this kind of network diagrams that you will see. So the same thing, to build a network, now we are using switches. The switches are layer 2 devices. Which layer device? Layer 2. And why do we call layer 2? Because these are also doing same thing, connecting your end host to build a single network like hub was also doing. But switch was smart. Whatever data they were receiving from any of its port, the they were the data will be having the complete information: source IP, destination IP, source MAC address, destination MAC address. And but the switch will only be able, now switch is very smart device because he's not layer 1, he's not receiving and sending data, he's also checking who is sending and to whom we want to send data. That's a special power. So for that it needs to check layer 2 information and only layer 2 information, and it cannot check anything else. To forward data to destination within the network, the switch use layer 2 information. Okay, one is that switch is a layer 2 device. And we have a special we have a special table, that was a specialty. We have a MAC address table. So guys, before going and discussing switch, I want to ask you one thing. Guys, according to this topology, if I ask you how many broadcast domain are there, we are having hub. So how many broadcast domain are there?
One.
One.
Yes, yes. Even okay, even you are having multiple, like control Z. So all, if any of the device sends a broadcast message, will be delivered to all these other devices. Okay, because of the functioning. And if I ask you how many collisions domain are there?
8.
8. Okay, one answer is 8. Anyone else?
One.
In Abdi you're asking?
How many
Single
collisions
collision.
domain are there?
Single.
Single collision.
Single.
One.
One collision domain, sir. So
One.
yes, you can see multiple path, but the functioning of hub, the functionality we are provided, we have only all the ports belong to a single collision domain. So if any moment both if two devices send data at the same time, collision will happen. So that was the problem. So now we'll go back to the switch and check what are the things here. So according to this topology, when we are having hub, we have single broadcast domain and single collision domain. Done. Now we are at switch. So switch have a special table that is known as MAC address table. So switch store information about the MAC addresses in its MAC address table. Yes, MAC address table will be having few more information, but the most important information is which MAC address, which computer is like connected to which port. For example, PCA will be having its own MAC address. PCB will be connected to this particular port. PCC is connected to this particular port. And let's suppose this is F0/0, F0/1, F0/2, the name of the port. According to this topology, if this switch is aware of these MAC addresses, so he'll be having like PCAA. I'm just writing the MAC address in smallest form to make you understand. AA is connected to F0/0. MAC address BB is connected to F0/1, and MAC address CC is connected to F0/2. So in MAC address table, he'll be having these information. By default, these information are not there. My switch is learning those information, and you should be also aware how it is learning. By default, every switch will be empty. So how he is able to understand which MAC address is connected to which port? We will learn that thing in today's session, guys. Done. So switch is a layer 2 device containing MAC addresses, have multiple port. Same are used to build a single local area network, not multiple network, just used to create a single local area network. That is good. And if I ask you about broadcast domain and collision domain and switch, one upgradation was having a special memory. Second upgradation was like broadcast domain is same, like all the ports, you are also all the ports of switch belongs to a single broadcast domain, because like hub switch is also used to make a single network, and if any of the device within the network sends a broadcast message, should be delivered to all the other device that is inside that network. So switch was also used to create a single network. A single broadcast domain is basically a single network. Okay, a domain where a broadcast message can be received to all the device within that network, and you identify network by IP address. Done. And what about collision domain, guys? This is special. All the ports of switch have their own collision domain. They are not having a single path for every port. Every path is having every path is different, and every path should have a different collision domain. So like if I transform the same network, let me copy it down, copy and paste. Done. This I have just copied it and just remove the hub. I have removed the hub. Okay, remove this hub also. And now we'll add the switch. I'm just adding switch over here. Okay, so I'm adding over here. 2960, this one over here, this one, same thing. Just to make the same network, now I'm using switch. So see, I'll be connecting these devices with cable. So right now for the starting part, just choose the first option, that is automatic. One end of the cable with PC and another one on the switch port. You need to do connectivity like this. Then these devices are there. And we need to provide connectivity between switches also, same like that. Okay, now same network we are building we are using a smart device, that is switch. Switch is learning something. You can see the ports are not ready. If ports are ready, they will get green. You can identify by the link. You will have LED lights over every port that helps you identify whether the port is working or not. Okay, done. So we have just IP address is also available here, and if you want to increase the time, you can just type it over it, click multiple times over here. Okay, we'll learn the power of this increasing the time. Why do we increase the time? So see here, now I have the same network. Let's try to do check ping. This is the first PC. I'll go to command prompt. I'll do ping 172.16.0.7. Enter. I'm getting a reply. That I was getting earlier also, but in background, whether we are sending data to all devices or just unicasting it. So see here, I just showed you the ping. I just showed you the ping, and we are getting a successful reply back. And if I show you in simulation mode how things are delivering to destination, see here, I'll go to the same device. I'll do the same ping. As soon as I press enter, a message will be generated. A request message will be generated. Okay, if you click on it, check the out layer. When we are sending out data from that port, we are adding who's sending. PCA is sending to whom we are sending, destination IP, that is source MAC address and destination MAC address. All information are there. Now when he sends data, switch receives that data from layer 1, then it checks the layer 2 information. That particular port that is receiving the data, it is checking the layer 2 information. At layer 2 is checking who is sending. Okay, PCAA is sending, and to whom he's sending. PC, let's suppose ZZ. Let's suppose PC7 is ZZ. Let's suppose that is not okay. So to a device that is ZZ. Now my switch will check whether he has information about the destination in the MAC address table or not, and he'll check whether the destination MAC address he is aware of, that the destination MAC address is connected to which port. So destination is not directly connected to this port, but he know to send the data to destination, he need to send data to switch 2. So he'll share the same data. Now he's not doing broadcasting. Can you see that? He's sending out data to the port, from the port where it can reach to the destination. He's aware of that information. He's aware from which port the destination is connected to. So now switch 1 has delivered the data to switch 2. When switch 2 receives the data, from that particular port, will receive data from layer 1 and then checks the layer 2 information of the same data. At layer 2, he's checking, this switch is again checking who is sending and to whom we are sending. So by checking the data link layer information, he will now this particular switch will check, okay, the destination is ZZ, so let me check the destination is connected to which port. If he is aware of that information, he'll send data directly to the destination. Can you see that? Now ping request is delivered to destination, and the destination will give you a ping reply back. When he's giving you reply back, he's generating a new message, a reply message. He'll be adding his own source IP. Destination IP will be of the earlier source, PCA. This source MAC address will be of this PC, and the destination MAC address will be of this now. So now we are sending the reply back. So he'll send the data. My switch receives switch this particular port that is connected to PC7 will receive data from layer 1, that is the physical layer, checks the layer 2 information, who is sending the MAC address and to whom we are sending destination MAC address, just checking the destination MAC address in the MAC address table. If he's aware of, just send out the data from the exact port the destination is connected to. Ta-da! Going to switch 1, he'll do the same thing, receive from layer 1 and checks the layer 2 information off from this port, and according to the destination IP, he's delivering data to the destination, guys. This is the smartest way, because this is how one thing is there, it is secure, and another thing is that, guys, network is a path. It's a road, it's sort of a road. If multiple people are there going with that road, you will find traffic, you will find congestion. When no one else is there, you will find, you will take less time to deliver the to go from source to destination. I hope when we are talking about real road, same thing is about network. It's a road, it has a specific limit of sending data. So if unnecessarily we are sending data to everyone, it will consume their capability of the path. That is known as bandwidth. That is known as bandwidth. Every path, every port has its own bandwidth. What is bandwidth? Maximum capability to send and receive data. Like for example, if like for example I have a road that have 2 lanes, so the bandwidth is at a single time I can 2 cars can go. So the bandwidth of this particular path is 2. So we have bandwidth in our network also. So bandwidth is the capability, the maximum limit, the maximum speed that you can send data from these port. Okay, so this is how things are working. So before going in depth, so that's the specialty. And if I talk about collisions, will collision happen in my switch? No, because each path has its own collision domain, and you won't find a collision over here, because all the because of these things. All the ports are having its own collision domain, and the most important thing, the ports of switch by default are working in which mode? Are working in full duplex mode. By default, all the ports of switch are working in full duplex mode. So that's why at the same time they can send and receive data. So be assured with what kind of information I'm saying. That is it. Now, guys, you are well aware how things are happening. So if I ask you guys, according to this scenario, how many broadcast domain are there?
1.
1. And ma'am, how many collisions domain are there?
2, 3. Is it 8?
Let's ask other also, guys. How many collision domains are there?
8.
8. 8. Yes, because every port has its own collision domain. So this particular link between PC and switch is a single collision domain. Single collision domain. Single. Okay. So right now, according, let's just check whether in simulation mode whether two devices can send data to each other or not. I'll just show you the connectivity part. In 172.16.0.4, we are getting reply back. Okay. Okay, see here. So what can happen in simulation mode? I'll go to PCA. I'll try to do the same thing. I'll try to ping. This person also wants to send data, and let's go to this PC. I'll again press up arrow, and these 2 person want to send data at the same time. Let's see, will collision happen, or they will the data will be delivered to specific destination. Let's see. Now in our network, 2 person are sending data. Okay, data is going one by one. So see, it is only delivering to the host. We are sending data. We are not having collisions over here. Can you see that? So one by one data will be delivered to every device. This is how things are happening. Now in switch, you won't be seeing collisions. No collision over here. Okay, that is good. Real time. So now, guys, it's a high time to learn how my switch is entering MAC address information. Is MAC address table. Now you are aware of, like, now you are good of, now you are not, now you are having a fundamental knowledge about switch. Why you will purchase switch? To build a single network. and you can find switches in multiple ports, and it will
Yeah, hello,
cost
Sumit.
you.
Can I ask one question?
Yes, yes, please.
First time when you have ping like PC1 to like PC7, which is connected with the switch 2 in the below.
Ye- Yes,
So, like how the switch 0 is like confirming that the device is connected with the switch 1.
yes. I'll like that. Just give me a minute. I'm just teaching you that how switch work. The topic is how switch work. Now you know the theoretical part. Okay, switch is receiving data, checking the destination MAC address in the MAC address table, and sending data. But that is theoretical, guys. You are the mechanic of the engine. You should know, you should be also aware how that particular engine is working that you're having inside your car. Not only the this is 2.5 liter turbocharged, not that theoretical part. You should be able to know what is the internal mechanism that we are going to learn just right now. Then the thing is how switch work, and this concept will solve your doubts, sir. How switch works. So right now we are learning that. So see, let's suppose, let me just build a small network, and according to that network we have two computer, we have a switch, we have another switch over here, and we have a computer over here too. I have built a single network for PM networking. I'm connecting my both of the switches to this computer, PCA, PCB, PCC, PCD. When you are having a network, you will be having a network ID. Let's suppose 172.16.0.0/24. Dot 1 is assigned to him, dot 2 assigned to him, dot 3 assigned to him, dot 4 assigned to him, and the MAC address for in our case, let's suppose AA, BB, CC, and DD. We have just provided the connectivity. So see here, guys. Now you are learning something that I haven't shown you, but you will learn something good. So guys, both switch 1 and switch 2 will be having their own MAC address table. Now we have just connected the device and none of them has sent any data till now. Let's assume that. So both the switches will be having their MAC address table. MAC address and to which port this particular MAC address is connected to. So guys, we should also be aware of the port name. So guys, these are the port name F0/0. Let's suppose this is F0/1. This is F0/2. This is different switch. So let's suppose we are connecting F0/0 of switch 2 to this switch. Okay. This is F0/1 connecting to PCC. This is F0/2 of switch 2 connecting to PCB, let's suppose. Okay. So both of the switches will be having empty MAC address table at the starting. According to our lab. Okay. Then so guys, see, the first thing you should the first thing, guys, switch do three things in background. Switch is performing three things. How switch work? It is performing three things in background whenever he's receiving any data. The first and the most important thing he's doing what? Just like you, he's also learning, because he's not having any information over here. So he should, are you clear? He should have capability of learning. So the first thing he should, whenever he receives any data from any port, whenever a switch receives a data from any of its port, the first and major task is to do learning. And what he is learning, guys? He'll be learning, as you know, the switch will be receiving a data. So see here, let me just give you an example. So PCA wants to send a data to PCB, let's suppose PCC, or maybe PCD. Okay, so PCA should be having that data. He'll be adding the source IP address of him PCA. Destination IP address should be of the destination, that should be PCD. Unique ask message source MAC address should be of PCA AA, and destination MAC address will be of PCD. AA and DD. The IP address is, I hope that is clear. .1.4. Okay, so PC have added all the information and shared the information from one of its port. The signals are shared too. So whenever a switch receives a signal, receives a data, so first thing he's doing is learning, and he's learning what? He'll be learning source MAC address. So see what happened. This is switch one, guys, and this was PCA that was connected to F0/0. Is it true? Okay, so when PCA sends the data, it switch one receives the data from F0/1, that is the layer 1. Then from layer 1 it is checking the layer 2 information also. After receiving the data, in that particular data it is having all the information, layer 3, layer 4, all the other layers information. But my switch will receive data from layer 1, and then also read out the data of layer 2. Till layer 2 he can check the data. Layer 1 is just receiving the signal, and layer 2 is reading the signals, reading the information. So at layer 2, the most important information is source MAC address and destination MAC address. So first thing he's learning, he's not learning the destination MAC address. He'll learn the source MAC address. He'll confirm, okay, I am confirmed that, like, in the source MAC address, PCA has added AA, and the destination MAC address is of DD. One thing is clear from switch one, that from F0/0 PCA is connected. He's confirming that. He'll first of all check the source MAC address, and he'll check the MAC address and will add it on the MAC address table. First thing, he's not concerned. He's not concerned about the destination. The first thing and major thing every switch do whenever he receives data from any of its port, check the MAC address of sender. Because one thing I am confirmed, that this particular port is connected to the sender, whosoever the sender is. Right now he's sending data to anyone else, but later on someone might also send data to him. So I'm confirmed that from F0/0 PCAA is 100% connected, because I'm receiving the data from PCA from this port. That is confirmed. So switch will learn the sender MAC address of that particular data, not the destination MAC address. First thing, switch is doing learning. The second task is to forward the data, guys. Forwarding, basically. First thing is learning, second thing is forwarding. Right now, the first thing he has done, learn the MAC address of the sender. So he has added, by learning I meant adding the information in the MAC address table. By learning I meant that. After doing that, he'll do forwarding. And how to forward the data? He'll check the destination MAC address, guys. He'll check the destination MAC address. And where he will check? In its MAC address table, whether my switch one is aware of the destination or whether he's not aware of my destination. These two things can happen. One, to send the data to destination, two things can happen. By checking the MAC address, that MAC address, the destination MAC address is present in my MAC address table, and other thing is not present in my MAC address table. The destination MAC address is not present in the switch one's MAC address table. Switch one does not know where the destination is connected to. It can happen. Okay, so if my switch is aware that destination DD is present to connected to F0/2, let's suppose, if the information is present, the destination information is present, he'll directly forward the data out from that port. That this simply means, let's suppose right now, when switch one, right now this is a fresh network, none of them has sent data. My switches were having empty MAC address table. When PCA sends data and received by switch one, the first thing he's doing what? Learning the MAC address of sender. That he has done. Now the second task of my switch one is to do what? Send the data to destination. The main, that's why we have bought the switch, not to just only learn. So to send the data, he's checking the destination MAC address. And right now, let's suppose if the destination MAC address entry was within his MAC address table, then he would have simply sent out the data from the port the destination is connected to. But in our scenario, my switch was not aware of where the destination is connected to, because we are having the second thing. Okay, the destination MAC address is not present in the MAC address table. So So what will happen when the destination when the destination MAC address table MAC address is not known by my switch? In this particular scenario, my switch perform flooding. It perform what? Flooding. And flooding is basically a term when switches when flooding is basically what? Broadcasting, like Hub was doing, because Hub was a dumb device. He does not know where destination was connected to. So to deliver the data to destination, he knows one thing: deliver, send out the data from all the other port. He was doing broadcasting. So this is the only scenario when switch will do broadcasting by himself. When when someone want to send a unicast message and switch is not aware where the destination is connected to, so at to deliver the data, my switch will do what? My switch will do flooding. The technical term is saying flooding, because PCA didn't meant to broadcast the data, but my switch was incapable of delivering the data to the specific destination, so that he is doing flooding. So at least the data can be delivered to the destination if he is inside my network. So my switch, according to my scenario, Arun sir, TJ sir, Jap, ma'am, everyone. So what? Because the destination is not known, what my switch will do? He'll perform flooding. That simply means broadcast the data from all the other port. So, okay. So what switch one will do? Will send the same data that was shared by PCA from to will do simply broadcasting. Will broadcast from F0/1 and F0/2, because these two are the port that are currently used. Okay. So we'll deliver the broadcast the same data from F0/1 and F0/2. Okay. So when PCB receives the data, it will simply drop, because destination MAC address is not of in the at the data link layer. When he'll receive from layer 1, then layer 2, he'll check the layer 2 information. PCB will check, okay, destination MAC address is not mine, so the data is not for me. This is drop over here. Now see, when switch 1 send data from F0/2 towards F switch 2, switch 2 will now receive that same data. So now what my switch will do? My switch will do the same thing. Will will first thing is what? Whenever any switch receives the data from its port, it will learn the MAC address of whom? Sender or destination, guys? It will learn the MAC address of source, whatever the source MAC address is above that data. So above the data, switch 2 will also see here. Okay, a source AA is connected to whom? My F0/0. This is F0/0 of switch 2. Okay, not of switch 1. Okay, right now we are having same, but just keep that in mind. I'm talking about switch 2. So switch to just check, okay, this to reach AA, I am connected to F0/0 of my, okay. So after learning, the second thing is what? Forwarding the data to destination. That is why you have bought the switch. So two things can happen. The destination MAC address can be present in the MAC address table. And if it is present, then directly forward out the data from the port the destination is connected to. And if that is not the case, that means that destination MAC address is not aware by my switch. Then in that case, my switch will do flooding, that is broadcasting. So what will happen over here? It will again broadcast out the data from all the other ports. So see, why we are not sending the broadcast out from here? Because we never send the broadcast out from the port we have received the broadcast message. You will send out the port from all the other port, but not the port from not the port from where the broadcast was received. So the same broadcast, same flooding will be shared from F0/1 and F0/2. So when PCC receives the data, PCC receives, it will receive from layer 1, then compute the layer 2 information. It will check, okay, destination MAC address is not mine, it is for DD. So PCC will simply drop over here at layer 2. But when PCD receives, the data was meant for PCD. So hence PCD will accept the data, and the data was received by PCD. So that my scenario was, we want to send a data to PCD. I do not want to get a reply from PCD. I want to send a data to PCD. That's how, if this is my scenario, that's how my switch will be having information. So you must be asking, sir, how will my switch will be able to identify these MAC address of PCDD, CC, and BB? See here. What if PCA sends a message that needs a reply back from PCD? What if PCA want to send a data to PCD from where you want to get a reply back from PCD? So now when PCD receives a message that was sent from PCA, And if that particular message I need to give a reply back to PCA, then what will happen? My PCD will generate a new message to, for whom? For PCA. So this is the reply that PCD want to give. Who is sending that reply? PCD. The source IP will be of PCD. To whom he is sending the reply back? To PCA. Who is the sender of that particular reply? PCDD. He'll add his own MAC address. Right now he's sending. And to whom he's sending? To PCAA, from where he get the request. If this is happening, in that case, what will happen? Let me clean it down, guys. So now my PCD is giving a reply. When he has all his information, you can see it's a unicast message. It will be delivered from, it will be sent out from PCD, and switch 2 will receive the same request, same reply. First, okay. So whenever a switch receives a message from any of its port, what is the first task, guys? Learning. So what he'll learn? Learn the MAC address of sender. Who is sending the data? At least I'm confirmed from this port I'm connected to this sender. Okay, that is I am confirmed. So right now, my switch will see, okay, the sender is PCDD. So this particular MAC address, the sender of the source is connected to which of my port? F0/2. Okay, done. Now after learning that thing, he'll do my switch 2 will do the second part. He'll forward the data. He needs to forward it. Na? So how he forward? By checking the destination MAC address in that particular data. Two things can happen. One thing, that is the destination is present, and one thing that destination is not present. So let's see, in our case, whether the destination is A, my switch 2 checks whether I am aware of whether I am aware that PCAA is connected to which port. Yes, my switch 2 is having an entry that a destination, the MAC address AA is connected to which port? To F0/0. To reach AA, send out the data from F0/0. So switch 2 will not, at this particular moment, my switch 2 will not do flooding. It will simply send data from the port the destination is connected to. So see here. So the data will be delivered out from F0/0, and it will be received by switch 1. Is it clear, guys? So now my switch 2 sends the data out from the port that the destination was connected to. Okay, now what is happening? The same data, the data that PCD want to send is received by switch 1. From which port? F0/2. So first thing my switch will do, learn the MAC address of the sender. So at that particular reply that PCD has sent, the sender MAC address is DD, and from which port the DD is connected to? F0/2. So you can see he's learning in this particular panel. So he have learned that thing, and after learning, what he'll do, he'll forward the data to whom we want to send, to PCA. Now my switch 1 will check whether I'm having entry of PCA. He was having entry, so that means the destination MAC address information was present. So he will simply send out the data from the direct port the destination is connected to. He'll not perform flooding. That is broadcasting that Hub was doing always. So now the data was delivered to PCA. Sir, like, I hope now you are a little bit confirmed what is happening in background, how switch works. Basically, switches were used to connect devices in a LAN. That is good. You were aware of that thing. And after that, I told you, if the destination address is within your network from where the source is, so switches are also capable to deliver the data to destination. But how? With the help of MAC addresses. So switches only understand MAC address information. They will be receiving all the information with the data layer 2, layer 3, layer 4, all the layers. But what he'll check, he'll receive from layer 1 and only check till layer 2, and will perform the forwarding according to the layer 2 information. That is happening over there. Is it clear? That is one part. So that's how my switches are able to learn. So see, if someone asks you how switch work, there are three things. Switch perform three things. You are aware of two part. First part is switch perform learning. Whenever switch receives a data from any of its port, it perform learning. Learn the MAC address of sender. After learning, he'll perform forwarding. He'll check the destination MAC address is present in whether the destination MAC address is present in its table or not. Two things can happen. MAC address is present and MAC address cannot be present. Done. So that's how it is forwarding. And the last thing, my switch is doing what? Is also doing loop avoidance. We'll talk about that, not right now, but these are the three things. These are the two major things. Switch perform learning, then forwarding, and he's also avoiding loops in background. There's a special protocol that helps switch to avoid loops. We'll talk about loops, not right now, but just keep that in mind. These are the three things that you should be aware. Switch first thing, how switch work, switch learns, then switch forward, and in background, switch is also avoiding loops. So these are the working. And there's one more thing, guys. See, so you can ask, so Matt, does this MAC address are always now the MAC address that switch has learned? Will these MAC addresses will always be there? No, sir. The MAC addresses that are learned by switches, these MAC addresses are dynamically learned. So whenever the MAC address is learned, these MAC addresses are learned only for 300 seconds. These entry will be only present till how many seconds, guys? 300 seconds. That is 5 minutes. After 5 minutes, these entry will be removed automatically from a MAC address table. And you know how will the entries will be present? Whenever they receive the whenever they receives a data, it will learn the source MAC address. Only learn the source MAC address. That is how they are learning. So whatever
You
MAC
can change. You can change that time too, right? I mean,
they
I know
can,
you'll talk about it later, but I think you
yeah,
can change that time.
change. Oh yeah, we can change the time. Yes, it is up to us. You also need to. Yes, this is a part of network engineering. So we can change that according to our requirement. But by default,
Sir,
His mic turned off.
is it only for me or he's
No, I can't hear him.
welcome back, guys. Can you hear me?
okay?
Actually, there's a light disruption at my place, so the Wi-Fi went like. So I just turn on my mobile data. Okay. So I hope my screen is visible. Let me also check whether we are recording or not. Yes, it is recording.
Yes, it's visible.
Yeah. So these things are happening in background, guys. We'll be learning, guys. It is right now. You are going good. I'm not teaching you. I'm not teaching you any command how to check your MAC address right now. Okay. But in the fewer session, like in the upcoming week, definitely we'll start about from switch and also learn how to configure switch, how to change these settings, and all the other stuff. Okay. Let's go back to here. Done. So before teaching you the commands, let me show you. Like I'll go over here. I'll go to switch. I have option of CLI. So basically, just showing you what you have to learn over here. Okay. So see here, I'm on the switch. So guys, just like you are having a computer, switches are also a hardware. Your computer is also hardware. Switches are also a hardware. Like your computer, you need to have operating system. Just like that, my switches also need to have an operating system. But that operating system is not like your operating system, like not your Windows, not your MacBook. It is an operating system just to operate the working of my switch. So every hardware that needs to do some smart work will be always having an operating system. Are you having a smart TV at your home? Your smart TV is a hardware. Above that, you're having a operating system. Within that, you're watching that TV and having that application. Okay, I'm just giving an example. So switches are also a networking device. These are hardware having operating systems, and within operating system, you are having two things. One is GUI and one is CLI. So within our switches, by default, we'll not get GUI, but we'll be getting CLI. So here in CLI, you need to perform commands. So by performing commands, you can learn a lot of things. So I'm switch one. I'm just not teaching you the commands. I'm just showing you. See here. And when I type a command in my switch one, show MAC address table. It shows the MAC address table of my switch one. Right now he has information about this particular MAC address is connected to F0/4. So I hope this F0/4 MAC address is RPC. This one. Okay. So these are the commands. There are multiple more commands that you need to be working on, but right now I'm not gonna illustrate you what I'm doing over here. I'm just showing you it's a special memory. You need to have these experience. Done. That is one part. So now you're well aware of what is the difference between hub and switch. And if I talk about router, guys, if I talk about router a little bit, so see, router are a networking device that are, we say it's a layer 3 networking device. What do we say? Switch is a layer 2 device and routers are layer 3 devices. Switches are used to build a single network and will be and switches are well capable to deliver the data if the destination is within our network. But if the destination is not within our network, switches are not switch will not able to send data to destination if the destination IP is not belonging to the same network from where the sender is. So if the destination is if the destination is someone else, someone other from a network, then we need to have router. And router is a layer 3 device. It's also smart. If I say layer 3, that means he's well capable of learning layer 3 information. So see here, to represent a router, the the networking diagram you will see a circle and sorry guys. So you will see a circular thing and arrow like this. So this is basically representing a router is there, and you won't be finding how many ports are there. You need to find it out. Okay, so routers are also having multiple port. So guys, routers are used used to provide connectivity to a different network. Routers are used to provide connectivity to a different network. So what is happening? Basically, the ports of routers are connecting to different network. If you assign same IP over here and same network IP over here, router will give you an error. It will say you cannot assign IP of same network to two different interface, because every interface of my router is connecting to a different network. And router, just like your switch have a special memory table that is known as MAC address table. Just like that, router has a special memory special table that is known as routing table. Router helps to deliver data from one network to another, but how? Router should have information about the destination network, how to send data to destination. So he'll be only performing the data to deliver to destination if he has information about the destination in its routing table. So in routing table of router, you are having routes are information about the network. Routes are what? Information about network. So guys, in internet there is not only one network, there are multiple network. So to each network you want to send data, your router should be having route to reach that. So your router, in your routing table, you can have multiple route to different destination information in your routing table. If your router have information about the destination in the routing table, he will be able to send data to destination. But if he does not have information about the destination network, where the destination network is, then in that case router will not send data to any other port. He will simply drop. Okay, see, your switches were not dropping the data. If the destination MAC address was not aware, they were flooding. Okay, but if the destination network information is not aware of routing table, in a routing table of that router, my router will simply drop. It will not do flooding. Okay, why? Because every port of router is connecting to a different network. And if we do flooding, that our data is very important to us, guys. That data can be ended to a attacker. So we do not want that thing. Instead, do not deliver data to anyone. Just drop it. At least my data will be secure. See, another thing, guys. See, if I ask you if I ask you how many broadcast domain are there in a router, guys, router is having all the ports of router are having their own broadcast domain. See, broadcast domain about router. See and all the port of router have their own broadcast domain. Basically, to make it more and easier than this word, every port, see, learn this, every port of router is connecting to a different broadcast domain, is connecting to a different broadcast domain. Every port of my router is connecting to a different broadcast domain. As I told you, every port of my router is connecting to a different network. So according to this, how many broadcast domain are there? One broadcast domain will be connecting to this port, one broadcast domain will be connecting to this port. Four broadcast domain, and every port have their own collision domain. Just like your multiple, every port have their own broadcast domain, every port of router have their own collision domain. Remember that, because router is not connecting in a single network, router is connecting to a different network. So let me draw a network for you and tell me how many how many collision domain and broadcast domain are there. I'm connecting my network to a different network, and let's suppose, guys, see, so help me, okay? So right now, if I talk about on the left hand side, how many broadcast domain are there? If I ask you in total, so see here, one thing you should be aware of, every port right now we have three routers over here, okay, and you can see switches and computer also. So if someone asks you how many network are there, so see, every port of my router is connecting to a different network. The port that I'm using between R1 and R2, yes, we connect like this also, we connect routers between routers, and between R1 and R2, let's suppose I'm giving the name gigs, this port is known as gig 0/1, this port is known as gig 0, sorry, gig 0/0 and gig 0/1 of R2. So R1 and R2 are connecting to a common network, guys. So between R and R2, we are having a single network. Okay, so we'll be having a single network between R and R2, a single network between connecting R and R2 over R2 and R3 over here, and a network connecting to R3 over here. So if I say how many broadcast domain are there, according to the scenario, I'll simply say four broadcast domain. How? One broadcast, every port of my router is connecting to a different broadcast domain. So the port here for R1 gig 0, for R1, the gig 0/1 is connecting to a different broadcast domain. R1 and R2 are connecting to each other. So here we have a single broadcast domain connecting these two. Then between R2 and R3, we are having a single broadcast domain, and here R3 is connecting to a different. So if so, what is happening actually? There here we will be having four network. In total, we'll be having four network. So how will we represent? Let's suppose this is the network ID running over here. 192.168.0.0/24 running over here. Between R1 and R2, we are having a common network. So let's suppose 100.0.0.0/24 between R2 and R3. Let's suppose I'm just 10 dot 1110.1.1.0/24 network over here between R2 and R3, and with R3 the LAN network we are having, let's suppose 172.16.0.0/24. So guys, in total, according to this topology, we'll be having four network over here. Every interface of my router is connecting to a different network. So here you will be running the IP address of 192. Okay, between R2 and R1, you will assign with between this network that is running between R and R2, one of the IP address you will assign here, and one of the IP address of this network you will assign on this interface. The network that is running between R2 and R3, one of the IP address you will assign on this interface, and one of the IP address you will assign on this particular interface that is common between R2 and R3 of the same network. That's why a single broadcast domain. I told you, a single network is what? A single broadcast domain. So how many broadcast domain are there, guys? Four broadcast domain. Is it clear, guys? TJ sir, Arun, ma'am, everyone. Any doubt? How many collision domain are there?
4.
Four collision domain. Are you sure? Every port of my switch
No,
has.
no, no. I'm sorry. I thought it said broadcast. So
Yeah.
domain, it's about I think 9 or 11. I counted.
Yes. Yes. So let me just highlight the collision domain:
Yeah,
one,
11.
two, three,
11.
4, 5, 6, 7, 8, 9, 10, and 11. The links between these devices are a single collision domain that I'm saying where collision can occur. Okay, so that's it. So guys, that's enough for today. That's, I hope, because after that I need to tell you a protocol. I need to tell you a lot about protocols before starting the configuration. We'll be discussing
Yes, sir.
protocols,
Yes, sir.
and we need to learn about cables also. So we learn that thing tomorrow. Any doubt with today's session, guys? Any doubt what we have learned till that?
No.
That's all for today, guys.
Hello.
Yes, sir.
So the like the switch are connected between them, so they will also send a broadcast now between them.
See here, where? Tell me about from which network you are considering? 192
Uh,
or 1?
192. Yes, yes.
Okay. So see here, what is broad? Basically, what will happen if any of these PCs? I'm telling one more thing, interesting thing. So see here, what is a broadcast domain? Where a broadcast message will be limited. Okay. So if any one of the device here, if like for example PCA sends a broadcast message, this broadcast message will be delivered to all the device, but within this network. My router will never send that broadcast out from any other port, because because he will never say, remember one thing: if router receives a broadcast message from this network, he will never transfer that broadcast message to any other interface, because the that particular router has a limitation. Every port of my router is connecting to a different broadcast domain, and a broadcast domain is a domain where all the people within that network will be assured to receive a broadcast message, but only within that network, not to other network. Okay. So if PCA sends a broadcast message, that broadcast message will be delivered to all the device within this network. But my router will simply, when it receives the broadcast message, it will keep it up to him, but he will never transfer the broadcast message from any other port. So if are you getting it what I'm trying to say? If router will transmit the broadcast message, so what will happen? If I want to do broadcast within my network, that broadcast will be shared to all the people in the internet, and we do not want that. So your switches will be delivering the broadcast message to all the other device within your network, but your router will restrict the spread of your broadcast from all the other port that he is connected to. Is it clear, sir? Little bit.
Yeah, yeah.
Okay. So any other doubt, guys? Any other?
Hello, sir. I have one doubt.
Yes, ma'am.
So, how many collision domain is there in this network, sir?
Ma'am, how many collision domain are there? Ma'am, see,
Yeah,
one,
sir.
two, three, four. I'm highlighting 4, 5, 6, 7, 8, 9, 10, and 11. Is it clear? Every port of my router is also having their own collision domain. Just keep that inside your mind. So this particular port between R1 and R2 are connecting to a single collision domain. Is it clear? A single collision domain over here, a single collision domain over here, a single collision domain over here.
And it's because those cables are full
Yes.
duplex. Those ports are full duplex, right?
Sorry, sir. No, like I didn't get it. Can you please say it? Say it again.
It's because the ports are full duplex is why those are collision domains, right?
Yes, yes. Also your interface are for router are working in full duplex mode. Keep that in mind. So yes, that's all. Okay, that's all for today. Thank
Okay,
you.
sir. Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank
Have a
you,
great
sir.
day, guys. Enjoy. Thank you.
Tomorrow.
Yes,
Thank
sir.
you, sir.